I have written 4 questions of quadratic equation on the left side of the board. Without solving, state the nature of the roots. Let's take the first question, that is 3x squared minus 7x plus 5 is equal to 0. Now a is 3, b is minus 7 and c is 5. A is the coefficient of x squared, b is the coefficient of x, which is minus 7, and c is the absolute term, which is 5. Now what I'll do is I'll calculate the d, which is b square minus 4ac, because that is the term which decides the nature of the root. Whole game of the quadratic equation or the nature of root will depend upon only the value b square minus 4ac. So it is minus 7 whole square minus 4 into 3 into 5. 49 minus 4 3s are 12, 12 5s are 60. So it will come out to be how much? 11. It will come out to be 11, I think. Yes, it will come out to be 11 negative. It is going to be minus. Now the question is, you don't have to write even the value, you don't have to calculate 49 minus 60. What is the value minus? I will have to write only negative. It is negative. It is negative. So if it is negative, roots are imaginary. Roots are imaginary. And if you remember what kind of curve I'll be getting for this, I'll be getting something like that, above x-axis. I'll be getting above x-axis because A is positive, so the parabola will be opening upward, and because it is imaginary, so it is not going to cut, the x-axis. Now let us see the second question. 4x squared plus 4x plus 1 is equal to 0. So A is 4, B is 4 and C is 1. Let us calculate the value of B square minus 4AC. Discriminant is B square minus 4AC. I need to know what is the sign, positive, negative or 0. So 4 whole square minus 4 into A is 4 into C is 1. So 16 minus 16 is equal to 0. So that means what? The roots are real. The roots are real. But same. I'll tell you why it is so. 4x square plus 4x plus 1 is a square of 2x plus 1 whole square is equal to 0. That means 2x plus 1 into 2x plus 1 is equal to 0. That means x is equal to minus 1 upon 2. X is equal to minus 1 upon 2. There will be two roots, but they are the same roots. It is a perfect square. If it is 0, it will be always a perfect square. And what kind of a figure will I be getting? If I draw this curve, I'll be getting something like this. Again, why will I be getting something like this? Because number one, it is a perfect square and it is equal to 0. The roots are going to be real but same. That is why it is going to touch x-axis at 1 point only. It is going to touch x-axis at 1 point only. And roots will be same, like I have calculated. X is equal to minus 1 upon 2, x is equal to minus 1 upon 2. So the same roots are there. Now next, third question. 3x squared plus 7x plus 2 is equal to 0. Again, what is the value of A? A is 3, B is 7 and C is 2. So D will be B square minus 4AC, and what will I get? 7 whole square minus 4 into A is 3 and C is 2. 3 into 2. 49 minus 12 to the 24. So it is 25. It is 25. You get 25, so it is positive. It is positive, so roots are real. Roots are real and distinct. And distinct. Again, what kind of a figure will you obtain? You will obtain a figure like this. Parabola cutting the x-axis at 2 points because roots are real. Real means they have to lie on the x-axis. Distinct means the curve shall cut the curve shall cut the x-axis at 2 points to make the roots to be distinct. Now the fourth part, x square plus px minus q square is equal to 0. A is 1, B is P, and C is minus q square. C is minus q square. Let us calculate the value of B square minus 4AC. D will be equal to B square minus 4AC, which will be, B is how much? P whole square minus 4. A is what? A is 1 and C is what? Minus q square. So you get P square plus 4q square. Now you will say, how will we decide that it is negative, it is positive? It is not equal to 0, that is for certain. It's not negative, that is also certain, because a square of any term cannot be negative. So P square is positive. Q square is also positive because a square term can never be negative. So it is what? Positive. It is positive. It is positive. The roots are real and distinct. Roots are real and distinct. Roots are real and distinct of this kind. Roots are real and distinct. Okay, now let's get further into the questions of quadratic equation. Like in question number 5, I have 1 plus m square into x square plus 2mcx plus c square minus a square is equal to 0. He says has equal roots. This quadratic equation, he says, has equal roots. Show that c square is equal to a square plus 1 upon m square. In the quadratic equation, like he has written, 1 plus m square into x square plus 2 mcx plus c square minus a square is equal to 0. Meaning that by the value of a is 1 plus m square. That is the coefficient of x square. B is the coefficient of x, that is 2mc, and c will be the term c square minus a square. Don't confuse this c with this c. Now, what is he saying? Has equal roots. Equal. When is a quadratic equation has equal roots? We told you if b square minus 4ac is equal to 0. This is the condition for equal roots. For equal roots. The condition for equal roots is this is the condition for equal roots. B square minus 4ac is equal to 0. So let us substitute the values of b and ac from this. B is 2mc whole square minus 4. A is 1 plus m square. And what is c? C square minus a square is equal to 0. Let us solve this equation. 2mc whole square means 4m square c square minus 4. Let us multiply 1 plus m square into this. it will be c square minus a square plus m square c square minus m square a square is equal to 0. And it is 4 outside, so 4 also will multiply. So 4m square c square minus 4c square plus 4a square minus 4m square c square plus 4a square or m square a square is equal to 0. When you multiply it with minus 4, all the signs inside the bracket would change. They will take opposite sign. It was c square, it became minus c square, it was minus a square, plus a square, plus became minus, minus became plus. 4m square c square minus 4m square c square will cancel. What do I get? I have to get answer in the form of c square. So I must keep c square on one side, the remaining term should be transferred to other side. So I keep minus 4c square here, and it will be equal to minus 4a square minus 4m square a square. Now minus 4c square, take minus 4a square common, take minus 4a square common, it will become 1 plus m square, 1 plus m square. Both sign negative are there, both sign minus 4 is there. I can divide both sides by minus 4. I will get c square is equal to a square 1 plus m square. And this is what you had to prove. This is what you had to obtain. Show that c square is equal to a square into 1 plus m square. Once again, I will quickly go through the question. He has given you a quadratic equation of the form 1 plus m square into x square plus 2mcx plus c square minus a square is equal to 0. So we took out what is a. A is the coefficient of x square, which is 1 plus m square. Coefficient of x is 2mc, and the constant term is c square minus a square. Now he said roots are equal. Has equal roots. This equation has equal roots. If it has equal root, then b square minus 4ac will be equal to 0. b square minus 4ac should be equal to 0. We substituted the value of b, a and c, and finally got the form which we wanted. It is simple calculation, simple multiplication, then whatever terms are there cutting, and then present the equation in the form which he is wanting. After this, let us rub it and see question number 6. Just look at the left side of the board where I have written question number 6. Question number 6 says, if roots of this be real and unequal. It says, if roots of ax square plus x plus b is equal to 0 be real and unequal. Real unequal means distinct. I had used the word distinct, here it is unequal. They are not the same. If the roots of ax square plus x plus b is equal to 0 be real and unequal, then show the roots of this are imaginary. He has given you another equation, x square plus 1 upon x is equal to 4 root ab. He says if the roots of this equation are unequal, real and unequal, if the roots are real and unequal, then what is the condition? B square minus 4ac should be greater than 0. What is the value of a here? A only. What is the value of b? 1. Coefficient of x is 1. And what is c? B. Don't confuse this b with this b. Now we are going to find for condition for roots real and unequal, real and unequal and unequal. What is the condition? B square minus 4ac should be greater than 0. B square minus 4ac should be greater than 0. So let us put the values and see. B is 1, so 1 whole square. minus 4a is a and c is b. So the condition is that 1 minus 4ab should be greater than 0. This is the condition for the roots being real and unequal for this particular equation. Now let us see that equation. It is x squared plus 1 is equal to 4x under root ab. So x squared minus 4x under root ab plus 1 is equal to 0. Now he says if the roots are real and unequal for this equation, then roots are imaginary for this equation. Now how do we do that? What is a? A is 1. What is b? Minus 4 root ab, and c is 1. And c is 1. And c is 1. So let us calculate the condition for it to be imaginary. Let's calculate b square minus 4ac. What does b square minus 4ac comes out to be? B square minus 4ac means the value of b is minus 4 under root ab whole square. Minus 4a is 1 and c is 1. I have to prove that this is imaginary. I have to prove this is imaginary. So what will I get? When I will square it, what will I get? 16ab minus 4. I can take 4 common, 4ab minus 1. Now please look here, for roots being real and unequal, the condition was that 1 minus 4ab should be greater than 0. If it is greater than 0, if I reverse then, if I suppose reverse the sign, you know what happens in inequality. If you reverse the sign, like if I make it 4ab minus 1, then it will become less than 0. What have I done? What have I done? Minus 4ab I converted to plus 4ab, and plus 1 into minus 1. I have changed the sign, or I have transferred this to this side and this to this side. When you transfer or you multiply with a negative sign, or you simply say that we are multiplying both sides of the inequality with a negative sign, and when we multiply both sides of the inequation with a negative sign, then what happens is the sign of inequality reverses itself. If it is greater than 0, then it becomes less than 0. So that means this is the condition, 4ab minus 1. 4ab minus 1, that means it will be negative. It becomes less than 0. It is less than 0 as 4ab minus 1 is less than 0 from 1, hence roots are imaginary. Roots are imaginary because both questions are related to each other. It is the same question but two equations. In one he is saying roots are real and unequal. In the another he says you have to prove roots are imaginary. Once again, we got 1 minus 4ab by the given condition 1 minus 4ab greater than 0. If I multiplied both sides with the negative sign, what happens? 4ab minus 1 will become less than 0. When I calculated here everything, b square minus 4ac, I got the value here as 4 into 4ab minus 1. And 4ab minus 1 is less than 0. That means the roots of this equation are going to be imaginary. The roots of this equation are going to be imaginary. Now let us see question number 7. He says alpha beta are the roots of this x square plus x plus 1 is equal to 0 are the roots of this equation. Alpha beta are the roots of this equation, and what I have to do is I have to find out the values of the given things. X square plus x plus 1 is equal to 0, and I have to find alpha cube plus beta cube, where alpha and beta are the roots of the equation. So a is 1 here, b is 1, and c is 1. A is the coefficient of x square, which is 1, b is the coefficient of x, which is 1, and c is an absolute term, which is 1, and I have to find out, he says alpha and beta are the roots of this equation. We have discussed just in this lecture only roots of the equation alpha and beta. So he says you have to calculate alpha cube plus beta cube. So alpha plus beta will be minus b upon a. We had calculated the sum of the roots of the equation is minus b upon a, that is minus coefficient of x upon coefficient of x squared. So it is b is 1, a is 1, so it remains minus 1. Similarly, alpha beta will be equal to c upon a, that is absolute term upon the coefficient of x squared, which is 1. 1 upon 1 is 1. Now he wants you to calculate alpha cube plus beta cube. You know that alpha plus beta whole cube is alpha cube plus beta cube plus 3 alpha beta into alpha plus beta. This is the formula for alpha plus, this is expansion actually. If you expand a plus b whole cube, a plus b whole cube is a cube plus b cube plus 3ab into a plus b. Instead of a and b, I have alpha plus beta, alpha and beta. So alpha plus beta whole cube is equal to alpha cube plus beta cube plus 3 alpha beta into alpha plus beta, or alpha plus beta whole cube minus 3 alpha beta alpha plus beta will be equal to alpha cube plus beta cube, which we want to calculate. Just substitute the values. Alpha plus beta is minus 1, so minus 1 to the power 3. Minus 3 alpha beta is 1, and alpha plus beta is minus 1. This will give you the value of alpha cube plus beta cube. Minus 1 to the power 3 is minus 1, and it will become plus 3. Minus 3 into 1 is minus 3, and into minus 1 is plus 3. So it will become alpha cube plus beta cube, or 2 will be the value of alpha cube plus beta cube. That is what he wanted. He wanted you to calculate the value of alpha cube plus beta cube. He had given you a quadratic equation, x square plus x plus 1 is equal to 0. What we did was, the first thing, a is 1, b is 1, and c is 1. After that, what we do is we calculate alpha plus beta, the sum of the roots. Sum of the roots is minus b upon a, which comes out to be minus 1. Alpha beta comes out to be equal to c upon a is equal to 1. Now he wants you to calculate alpha cube plus beta cube. So for calculating alpha cube plus beta cube, alpha plus beta whole cube is equal to alpha cube plus beta cube plus 3 alpha beta into alpha plus beta. I wanted to calculate alpha cube plus beta cube, so I keep it on that side only, and the remaining terms I bring this side. Alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. I substitute the value of alpha plus beta, which is minus 1 to the power 3, minus 3 into 1 into minus 1, that is minus 1 plus 3 is equal to alpha cube plus beta cube. So the value of alpha cube plus beta cube will come out to be 3 minus 1, that is 2. It is very simple. You just have to follow. It's just technical, nothing to understand much in that. You have to remember the formulas, that is all. You must remember the formula. There is nothing much beyond that. Now question number 8. Alpha beta are roots of p squared plus px plus q is equal to 0. Alpha beta are the roots of this equation. So a is 1, b is the coefficient, p squared sorry, the question is wrong. Question is wrong. It has to be p square. No. It is x square, not p square. It is x square. It is x square, not p square. It is x square. X square plus px plus q is equal to 0. So a is 1, b is p, and c is q. Now he says alpha beta are the roots of this equation. You have to calculate. This is x square plus px plus q is equal to 0. He says you find out alpha 4. There are two things you have to find out. Alpha 4 plus alpha square plus beta 4, and also you have to calculate alpha cube beta. First thing you have to find alpha cube beta plus alpha beta cube. Alpha beta cube. If alpha beta are the roots, then alpha plus beta will be equal to minus b upon a. That is, how much will that be? Minus b. And what will be alpha beta? Alpha beta will be c upon a, that is q. Now I have to calculate the value of that. Alpha cube beta plus alpha cube beta plus alpha beta cube. Yes. Alpha cube beta plus alpha beta cube. So I'll take alpha beta common. It will be left. Alpha beta I have taken out common. Alpha square plus beta square will be left here. It will be left alpha square plus beta square. Now how do I get alpha square plus beta square? How do I get alpha square plus beta square? Alpha plus beta whole square is equal to alpha square plus beta square plus 2 alpha beta. The value of alpha plus beta is minus p. Minus p whole square is equal to alpha square plus beta square plus 2q plus 2q. So alpha square plus beta square will be p square minus 2q. You will get p square minus 2q. And there was, we wanted the value of what? Alpha beta into alpha square plus beta square. I have got the value of alpha square plus beta square as this. And alpha beta is what? Q. So it will be q into p square minus 2q. This is the value of alpha beta. This is the value of alpha cube beta plus alpha beta cube. This is the value. The second question we have to calculate is alpha 4 plus alpha square beta square plus beta 4. The second part of the question. Let me write that down. First of all, let me go through this. X square plus px plus q is equal to 0. A is 1, B is P, C is Q. So I calculated the sum of roots as minus B upon A, which came out to be minus P. And I calculated the product of roots as C upon A, which came out to be Q. And then I had to calculate the value of alpha cube beta plus alpha beta cube. Alpha cube beta plus alpha beta cube. Out of that, I took out alpha beta common. I was left with alpha square plus beta square inside. So first of all, I'll calculate alpha square plus beta square because alpha beta I already know, which is q. So alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. The value of alpha plus beta we have written as minus p whole square is equal to alpha square plus beta square plus 2q. Alpha beta is q, so 2q. So we got the value of alpha square plus beta square as p square minus 2q, but I wanted the value of alpha beta into alpha square plus beta square. For that I wrote alpha beta as q into p square minus 2p square minus 2q. Now let us see the second part of the question. In the second part, I have to calculate alpha 4 plus alpha square beta square plus beta 4. I have to calculate alpha 4 plus beta 4. Okay, it is not a perfect square. If it was 2, it would have become a perfect square. So what I will do is, I'll use simple algebra, alpha square plus alpha square beta square plus beta 4. I will add alpha square beta square and I will subtract alpha square beta square. What have I done? I have added, I have subtracted the same thing. So basically I am adding 0. Alpha 4 plus alpha square beta square plus beta 4. Then this is not a perfect square. It should have been 2 here to make it a perfect square of alpha square plus beta square. So I want to bring 2 alpha square beta square. So what I'll do is I'll add alpha square beta square. But I cannot just add it. So I will subtract also alpha square beta square so that I am adding 0 to the equation. So I'm not basically adding anything. So now it will become alpha 4 plus 2 alpha square beta square plus beta 4 minus alpha square beta square. This will become alpha square plus beta square whole square minus alpha square beta square. Okay. Now you know the value of alpha beta, and alpha square plus beta square I can calculate. Alpha plus beta whole square is what? Alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta, which is alpha plus beta whole square minus 2 alpha beta is equal to alpha square plus beta square. The value of alpha plus beta is how much? Minus p. So p square minus 2q. This is the value of alpha square plus beta square. This is p square minus 2q. Let me put the value here. P square minus 2q whole square minus, what is the value of alpha beta? Q. So it will be q whole square. I can open out the bracket, P4, or you can just write as difference of a square. P square minus 2q plus q, one factor, and p square minus 2q minus q, another factor. It will become p square minus q, and it will become p square minus 3q. This is your answer.